Okay, welcome back. So now we're going to look at one of the last main types of motion in this course. Don't worry, there's still plenty of things to learn. But in terms of our journey of motions, we realized that there's only really three kinds of things we're focusing on. And just to summarize, right, we have started with looking at just one-dimensional linear motion. And this time, because we're going to go to circular motion, I want to emphasize that it's linear, so it goes along a line. Okay, so that's what that means. And when we look at 2D motions, the only thing, well, that clearly goes on a line. So either it just goes up and down, left and right, or the most complicated thing is it goes down the slope, right? In that case, you just tilt your axis, tilt your one-dimensional axis, and then it's still a 1D motion, essentially. But then we move on and we looked at projectile motions. It's a very specific type of motion, but it's genuinely 2D, right? Well, it's generally making full use of the X and Y directions. We realized that although that looks like a very complicated curve, it actually is very easy to analyze because you basically just split it into two one-dimensional motions, right? You split into the kinematics variables in the X and the kinematics variables in the Y's. So it's basically just doubling whatever you do with 1D motion, except for the time is shared between them. And now we're going to look at the third one. It's also two-dimension and it's circular motion. So at first, you will immediately think that, well, there's nothing in the world that is really a perfect circle, but we're going to go in the standard physics mentality. So by now, I guess you're more and more familiar with this. We will idealize the situation. And of course, in real life, you are absolutely correct. Very few things are going in absolutely perfect circles. Even electrons around atoms don't necessarily go in perfectly circular motion. So what's the point of learning this? But that's exactly just like the point of ignoring air resistance, ignoring friction a lot of times. It's not because we're not aware that they're there. Physicists are perfectly aware of that they're there. This is a standard criticism from especially mathematicians who say we don't do things precisely in physics. But we actually, that is really just the first order thinking. If you really understand what's going on, what physicists is doing is take a situation and we immediately use our intuition and use our experience to determine what is the most important criteria, what is the most important feature, and analyze that features first. We're well aware of everything that is what we call second order effect, right? There's so there's first order effect, second order, third order, fourth order, going in least and least importance. And then we start to include those and make the situation more and more correct. All right, you might go, so you might think, well, why don't we just study the most correct one right away? Well, number one, it takes time. If you want to study everything in excruciating details, then you will need to dedicate a whole lot of time to get a very, very accurate answer. While physicists can look at it and just get immediately in 1 second can get a very quick, or maybe not 1 second, but just a few lines of equation and analyze the most important stuff and get a quick estimate. If you want more decimal place, I will go and add the secondary effects, the tertiary effects, second and third order and fourth order, and so on, right? So in some sense, that is why, in my opinion, in the very first class, I said, physics is one of the simplest subjects I can think of because you study things with the simplest thing first. And a lot of confusion, I don't claim that this is the only confusing part in physics, but a lot of students find physics confusing. One of the reasons is they're overthinking it. And they're thinking, wait, there's a lot of other effects. The good thing about studying physics is you don't have to care about it. So if you study engineering like you will have to look at every excruciating effects, but we are looking at a big picture, looking at what's the most important thing and analyze that. Even with 1D linear motion. I think one of you very correctly pointed out that even if you go down a slope, right, it's not perfectly a slope. The mountain could have some curvature, like gentle curvature. But does that change the time a lot? If you travel a long distance from the top of the mountain to the bottom of the mountain, and you calculate with Suvat variables, it will take you, let's say 10 seconds. If you have a small curvature, maybe the answer will change to 12 seconds. Sure, that's 20% off. However, I will have an estimate of around 10 seconds, and I can do a lot of things in real life with with just that degree of accuracy. And a lot of things you don't need to go to 5 decimal places or 13 decimal places, and a lot of things you just need a good rough estimate. And if you need more, you can actually go in and study the next level and go on and do that. But good news for you, long story short, is we focus on the simple things first. So we're going to look at motion that goes in perfect circle. And as far as we're concerned, you'll see problems like the Earth going around the sun. It's not a perfect circle, but again, it's pretty close to it, actually. So that's a good approximate. Even with things like you can drive around a car going in circles, going around a roundabout, a roller coaster going through a loop, and yeah, a lot of things. We'll see a couple of problems as we go, right? So we'll the strategy is we'll talk about the main concept of how to make things go in a circle, and then study the kinematics of that. Give you a couple of new definitions, and anytime you study a new thing, you want to always, this is one of the first things to start with, to learn the definitions in it. Then we'll look at the classical problems of it. If you can solve them, you'll get the key idea of it. And if we get time, I will show you where some of the equations that I'll just show you come from. Okay. All right. So let's start with the concept.